Hey there, POA. This is for homework 2.3. Hopefully the test went well for you guys today, and then we have this homework assignment for you, which is just so nice to us. So let's go ahead and give it a try and see what we can do. It says use the mathematical problem-solving routine as you answer these questions. If you have trouble remembering the steps, refer back to the lesson problem-solving routine in this topic. The Wildcats basketball team scored 18 points in the first half of the game. All the points came from either 2 or 3-point baskets. If a total of 8 shots were made, some 2-pointers and some 3-pointers, how many of each type of shot was made? Okay, so I'm going to start in my understanding step, and so I'm going to think about what this problem is asking me. I'm going to try to put it in my own words. I'm actually going to try to write that down first, and I'm going to label this I'm actually going to zoom in considerably. Understand. So this is my first step in my problem-solving routine, and I'm going to try to paraphrase it. So I'm thinking a basketball team scores 2 and 3-point baskets to get 18 points. And just to be clear, I'm getting that information from right up here. There's 18 points. All the points came from 2 or 3-point baskets. And so I have another piece of information that I haven't included in my summary yet, which is right here. And so I'm going to include that in my summary. They made 8 shots. So they made 8 shots, and the question is, how many of each? So all I did was try to paraphrase it. I have a clear sense for what my question is asking me now, and so I need to now come up with a plan, which I'll do in orange here. So I'm thinking I will guess and check in an organized chart. I'm just going to predict an answer here. I think maybe like 4 2-pointers and 4 3-pointers. I don't know if that's right, but I'm just guessing. I know it has to be 8 shots total, so I'm just going to split it down the middle. That seems like a nice starting guess. And so let's go ahead and start making a chart here. I'm going to make my pen black for this part. I'm also going to do this. Okay. So let's see what we can figure out. So I think in my chart I'm going to make a 2-point shots column, 3-point shots, total points. Alright, so my first guess is just my predicted answer. I'm going to do 4 2-pointers and 4 3-pointers. And I think maybe I'll have a work column over here to help me out with this. So I have 4 2-point shots. That's 4 times 2 plus 4 3-point shots. When I do that calculation, I get 8 plus 12. That's 20 points. So that's 20. And so that's not it. I needed to get 18, so that can't be right. I need to try another guess. Alright, so I did do a good job making sure I had a total of 8 shots, so I need less points, so they can't score as many 3-pointers, which means I'm going to make it 3 3-pointers, and since I'm going to do 3 3-pointers, to get 8 shots I have to have one more 2-pointer. So 5 plus 3 is still 8 shots total, So now I'll do 5 times 2 for the 2-point shots plus uh, 3 times 3 for the 3-point shots. So that's 10 plus 9, that's 19 points. I'm a little bit closer, but I need to get to 18 points, so that's not good enough. Let's try one more guess here. So again, I need less points, so that means I have to score less of the high point shots or the 3-point shots. So I'm going to go down to 2 3-pointers. And because I went down 1 3-point shot, I have to trade that out for a 2-point shot. So I'm up to 6 2-point shots now. And so then I do 6 times 2 for the 2-point shots plus 2 times 3 for the 3-point shots. And that is 12 plus 6. That's equal to 18 points. And I've got 18 points. And so I'm going to highlight that because that is the correct answer for me. And I'll zoom out. And so I've executed my plan. I used a guess and check method with an organized chart. And so now I'm going to double check my arithmetic. And I'm just going to use a different method. And so this I'll do in red. This is our look back step. So my answer was 6 2-pointers, so I'm going to do 2 plus 2 plus 2 plus 2 plus 2 plus 2, 1, 2, 3, 4, 5, 6, plus 2 3-pointers, 3 plus 3, and so 2, 4, 2, 4, 6, 8, 10, 12, plus 3 is 15, plus 3 is 18. So I just double check my answer using a slightly different method instead of using the multiplication. And so now my problem solving routine tells me I need to think about what I learned. I'm going to just report my answer to start that. They scored 6 2-point shots and 2 3-point shots. I think I'll make a little reflection box here. So I'm going to write it's important to think about trades because we traded 3 points for 2 points to try to reduce the amount of points they got total. And charts help me to organize my work. And so we've used the entire problem-solving routine to try to solve that problem. All right, let's look at this second half of this game. The second half of the game, the Wildcats again scored 18 points. However, we don't know how many total shots were made. List all of the possible combinations of 2 and 3-point shots that could total 18 points. Include a sentence explaining how you know that you found all the possible answers. Okay, so we have to answer the question and do a little bit of writing. And so I'm going to again use my understanding step. And most of those look like letters. So to understand it, I'm going to put it in my own words again. Find all combos of 2 and 3-point shots that make 18 points total. So now I need to come up with a plan. So my plan is I think I'm going to use an organized chart again. I'm going to write organized sequential chart because I think I'm going to try to organize my work that way. And I think there are going to be 10 combinations. I'm not sure, but that's my guess. Okay, so let's execute my plan. So I'm going to have 2 pointers, 3 points, and this table might get kind of big, so I'm going to make it large here. 2 points, 3 points, total. And then, well, let me do this. I think this time I'm gonna need a total shots just to make sure. Oops. I think that might be interesting to look at because it might change throughout. And then total points. And I'll have a work column again out here at the side. So the total points should always add up to 18. I'm going to start by guessing a number of 2-point shots. I'm going to guess that I got 0 2-point shots. And I'm going to go sequentially, so I'm starting with the smallest possible number of 2-point shots. So if I think about if they had just 3-point shots, that means 3 pointers, 3 points per shot times something is 18 points. I'll clear that up a little bit. So I know I need to get 18 points. And so the question is how many 3-point shots make 18 points? And I think 3 times 6 is what you get there. And so 3 times 6 is 18, so that means I made 6 3-point shots. That means I had a total of 6, because 0 plus 6 is 6 shots. And I made sure that I got 18 points. Okay, so it seems like I can shoot 0 2-pointers, and was it the Wildcats? Yeah, the Wildcats can score their 18 points. So that's the first row. Let's try 2 2-pointers, or sorry, 1 2-pointer. And so now I got to think, if I have 1 2-pointer, that's 18 minus 2 points leaves 16 points left over that could be 3-pointers. And so I need to think of 3 times something equals 16 points. And now I'm thinking about that. 3 does not go into 16 nicely, so I can't take anything times 3 and make 16. So that means you can't make a just one 2-point shot because there's no number of 3-point shots that will work. So I'm going to put an X here because it doesn't work, an X here because it doesn't work, an X here because it doesn't work. Alright, so I found a combination that didn't work. Let's try 2 2-pointers. And so that's 18. 2 2-pointers makes 4 points. And that leaves 18 minus 4 is 14. And 3 times something equals 14 points. And again, I run into this problem that I can't multiply 3 by anything to get 14, because 3 goes into 15 nicely, but not 14. And so again, there's nothing that goes in that space. So 2 points doesn't work. Or sorry, 2 2-pointers doesn't work. Let's try 3 2-pointers. And so if I have 3 2-pointers, that's a total of 2, 4, 6 points. 18 minus 6 equals 12. And 3 times what equals 12? Alright, so 3 times something equals 12, and I believe that something is 4. And so 3 times 4 equals 12. That means I could make 4 3-point shots. That would be a total of 7 shots. And my total points would be, let's just double check. This would be 6 points. This would be 4 times 3 is 12 points. And so 6 plus 12 is 18 points. Cool. So I found a combo that works. And I'm going to start highlighting the combos that work. And you can highlight your own work on your paper if you want. There's certainly no rules against that. So I've got 2 combos that work and 2 combos that can't work. Let's keep going here. So I'm going to try 4 2-pointers. And I'm thinking, I noticed something here. The 2-pointers, I had to get up to a point, a number of 2-pointers that made 6 points. And so I think you have to be able to trade 2 pointers for 3 pointers such that the 2 pointers are worth something that's divisible by 3. And that's a pretty complex thought. So let's just test this one out to test that. I don't think this one's going to work. So I'm going to look at 18 minus, this is going to be 8 points. And so 18 minus 8 gives me 10. And there's nothing I can multiply 3 by to get 10. So that's an issue. So this one doesn't work. I think I'm going to get a little bit creative here and make it so that I can add a page and continue my chart nicely. Oops. So I'm going to try 5 2-pointers, and so that'd be a total of 10 points. 18 minus 10 gives me, let me clean that up. 18 minus 10 gives me 8 points, and 3 times something would have to give me 8, and there's nothing that goes there. And so this is another one that doesn't work. And I think, again, I'm noticing this pattern. If this number of points that the 2 pointers make, so here was 4 and here was 2, it has to be divisible by 3. 6 is divisible by 3, so that's why this one worked. But 8 and 10 are not. So let's try the next one. I think it might work because it went works, doesn't work, doesn't work, work. So it seems like the next one will probably work. Alright, so I have 6. That's going to make for 12 points. So 18 minus 12 equals 6. And so then I have 3 times something equals 6. And that something is 2. So I can shoot 2 3-pointers. Whoops. And that'll make 6 points. And so that would be a total of 8 shots. And 12 and 6 make 18 points. So that works. I'm going to highlight it because that's another column that works. So I think at this point, if I try 7, it's not going to work because I've noticed this pattern. It works here, doesn't work, doesn't work, works, doesn't work, doesn't work, works. And so 7 and 8 aren't going to work, and so I think maybe I should just jump to 9. And so if I have 9 2-pointers, that's going to make 9 times 2 is 18 points. And so 18 minus 18 gives me 0 points left, so 3 times something equals 0, and that something is 0, because anything times 0 is 0. And so 9 gives me 18 points, no points left over for 3-pointers, and now I have a total of 9 shots and 18 points. And I found another one that works. And so I was totally wrong. I thought there might be 10 combinations that would work, and it turns out that there were only 1, 2, 3, 4 combinations that would work. And they were sequential. 2-point shots jumped from 0 to 3 to 6 to 9, and 3-point shots jumped from 6 down to 4, down to 2, down to 0. So let's process this a little bit because it told us to write a sentence. So let's say that, oops, I'm still on the highlighter here. There were 4 possible combinations of 2 and 3-point shots that would make for 18 points. I am sure I found all of them. Because I found a pattern for when a combination works. And again, that pattern was that for 2-point shots, every third shot, it jumps from 0 to 3 to 6 to 9. So the number of 2-point shots is like counting by threes. And so that's what I noticed, and that's how I know I got all of the answers. So let's do the look back section. So I think the thing that I can remember about this is that when making a table, always look for patterns. It can speed up your work. Cool. So that is the front page done. Those are 2 big problems, and we used our problem-solving routine for both of them, which is great. So let's keep looking. We've got a couple of things to look at on the back here. We've got this square box problem. And so when you're looking at the square box problem, remember the numbers have to multiply to make the top number, and they have to add to make the bottom number. And we're talking about this number and this number. So -2 plus something gives me -6. Plus something equals -6. And so it's a number that's going to make -2 more negative. So I think it also has to be negative, and I believe it's -4. Because -2 plus -4 is -6. Another way you could have figured that out is you could do -6 minus -2, which is -4. So now we need to figure out -4 times -2, and because it's negative and negative, it's going to be a positive, and 4 times 2 is 8, and we don't have to write the positive sign, so there we are. It is 8. Alright, so let's look at Pascal's triangle here. So we have to try to stare at this, observe a pattern, and then complete the next row. So I'm going to write row 5. Alright, so the first thing I notice is that the outside here, I'm going to highlight and then erase stuff. The outside is always 1. And so I'm going to write 1 and 1 on the outside because that matches the pattern. Okay, so let's try to identify how these other numbers are going. So I see that this is going by 1, 2, 3, 4, and so the next number down has got to be 5, and that's because of that pattern. Alright, and I'm highlighting just to show you how I'm getting the patterns, and I'm noticing the same exact pattern here. 1, 2, 3, 4, and then that should be 5. Okay, so let's see if we can notice another pattern. It's kind of hard to see because I see 1, 3, 6. That's difficult to know what would come next because it jumps by 2 and then it jumps by 3 and maybe it jumps by 4 next. It's hard to say. Let's try to find another pattern. So I'm going to get rid of some of my highlighting here. So I'm looking at this and I notice that 1 and 1 make 2. And 1 and 2 make 3. And 1 and 3 make 4. 1 and 4 make 5. So it seems like the number that is diagonally between 2 numbers in the previous row is the sum of those numbers. So I can also look at 3 and 3. Let's try to see this. 3 and 3 make 6. Okay, so that seems like a pattern that's working throughout the triangle. So 4 and 6 make 10, and it did go plus 2, plus 3, then plus 4, and then 4 and 6 make 10 again. Alright, so I think that's it. So the major pattern, it seems like, is that the numbers add together. So like two numbers like this add together to make that number, which I can zoom in to maybe see a little bit more. It's a hard pattern to see. So 1 plus 2 gives you 3, and 3 plus 3 gives you 6, and 3 plus 1 gives you 4. So there's a pattern there in which two numbers create the number that's below. All right. So how many different ways can you arrange letters B, C, and D? Make a list. Explain how you know that you found all the possible arrangements. So, well, you could definitely just go B, C, D. And I'm going to try to do a list where I start with the same letter each time and find out all the things that could start with that letter. So let's think of anything else that, any other sequence that could start with B. So I have B, C, D, but I could switch C and D, so that could give me B, D, C. And I don't think there's anything else that could start with B. So now I'm going to try to start with C. And I could go C, B, D. I could also try C, and then switch B and D and get D, B. Again, there's no more switches I can make so long as C stays in the front. So now I'm going to try D. So D, B, C works, and D, C, E works. And so it asked me to explain how I know I found all the arrangements. I'm going to say I found all of the arrangements by choosing the starting letter and finding all of the combos. Okay, let's search for patterns in the table, then use those patterns to complete the next 3 rows of the table. So let's look at the inputs. I see -3, -2, -1, 0. So that's just going up by +1, +1, +1. So it's going to go up by +1 again, and I'll get 1. +1 again, and I'll get 2. And +1 again, and I'll get 3. So that was just inputs add 1 each row. Okay, so let's get outputs. To go from 15 to 12, I take away 3 because it got smaller. 12 to 9 takes away 3, and 9 to 6 takes away 3. So I think I'm going to keep taking away 3 to follow that pattern. So that would be 3. 3 minus 3 is 0, and 0 minus 3 is -3. And so outputs subtract 3 each row. All right, last 2 problems. The school survey showed that 30% of students bring their lunch to school. The survey polled 300 students. How many of the 300 students do not bring their lunch to school? Okay, so 30% means 30 out of 100. So if you have 300, means 30 plus 30 plus 30 bring their lunch. Because there's 30 for every 100, and this is 300, so we have 3 30s. And so 90 bring their lunch. But it asks us how many do not bring their lunch. So I'm just going to see how many are left over after you take away those 90. And so I have 210 don't bring lunch. So that's just one way of thinking through the problem. You could have also noticed that if 30% is just another strategy, 30% bring, well, you can only have 100% of something, so that means 100 minus 30%, 70% don't. And that's 70% of 300, and I can just do 70% times 300, which is 70% of the decimals, 0.7 times 300, and that's 210. So I can get it either way. What's the value of 1.93 times 71.4? Place the decimal point in the correct position. Okay, so there's a couple ways you could do this. You can crack it out on a calculator, which I'm going to do first. I'll do that second, and then I'm going to check my work. So if I remember right from when I was doing this in, I think, 6th grade, when you multiply decimals, if you count the number of digits after the decimals, that's going to be the number of digits that are going to be total after the decimal in your answer. So I believe it's going to be 137.802, but I'm going to check my work just to make sure. And so I'm going to get my calculator pulled up here. Whoops. Let me try a different calculator. So 1.93 times 71.4. And I just double checked my work to make sure I was right, and I was totally right. So the decimal point goes right there. I'm going to say that the total number of digits after the decimal point in the original numbers is the same in the answer. And that is 32 minutes, and we're totally done with our homework. That's I think 9 problems, or 6, oh, I guess 8 problems, but 2 really big ones on the front. Thanks for watching this video. We'll see you on Tuesday after your nice long weekend.